All right, welcome to class. In this video, we are going to be talking about the fruits. So recall that we said that the ovary gives rise to the fruit. So before we get into the discussion of fruits, let's quickly do a quick recap on what we've covered so far before we go to fruits. Now we've talked about pollination, and because this is all about the plant reproduction, right? So we've talked about pollination, which is transfer of pollen grain from anther to stigma, and immediately after pollination is fertilization in it. So after fertilization, then we have what is called the fruit. The fruit. I mean, of course, in the seed we have the seed. The ovum germinates into the seed, which forms a new organism. And of course, this fruit is a product of fertilization as well, the fertilization of the ovary. So the ovary develops into the fruit, as we have said. And from seed, we can also, we are going to go into, or we're going to be seeing how seeds are dispersed. Is that okay? We call the process seed dispersal. Then from seed dispersal, after dispersal, it will germinate into a new plant. Seed germination. Okay? So, and that cycle now repeats itself again. Does that make sense? So now we are on fruits. Now, fruit is basically defined as a product of flowers that are usually developed as a result of flowers being pollinated. They are, this is the botanical definition. Is that okay? Flowers that are being pollinated give rise to what? A fruit. Is that okay? And it is referred to as a ripened ovary. So as I reiterate, I said the ovary becomes the fruit, as well as the oval becomes the seed. Don't forget that. Okay, so it is a primary, its primary function is to distribute seeds to new areas where plants might grow. That's seed dispersal. So the primary function of the fruit, there are two functions. Number one is protection of the seed, and the other one is what? Dispersal of the seed. Seed dispersal. Okay, that's the primary function of the fruit, just for continuity of the generation. Is that okay? So for seeds, when seed is dispersed appropriately to the right place, it's going to germinate into a new plant. So then the generation of that plant continues. So that's one of the major functions. But the other function is protection of the seed. It protects the seed from desiccation, from drying out. All right. So now let's talk about the fruit structure, the fruit structure and classification. All right, now the structure of the fruit is such that it is composed of a pericarp and a seed. Those are the two major parts of the fruit. Now, a fruit will typically look like this. Will look something like this. Now, I'm going to stress something quickly about your biology in class, in your exam rather, in biology exam. So where you have to draw or write. Now make sure that your drawings are accurate and they are exactly the scale that you are given. Is that okay? Don't draw with another scale. Don't use another scale. Don't be smarter than your examiner. Use the scale that you're given. Is that okay? Use the given scale. Okay, so that is what can earn you the mark. Then of course, I mean the size, is that okay? And then check for your magnification also, and also make sure that the labels are done on one side. Usually for a biology group, it is preferably the right side. Is that okay? So a typical seed consists of some three parts, which are the outer part, this inner part, and this innermost part. This outer part, we call it the epi or exocap or exocap or epicap. Is that okay? Epi or exocap. If you know the word exoskeleton, you know what that means already, right? Then epi also means outside. Is that okay? And of course, I've told you that the word carpus means fruit. So if you have not seen the video that I sent on 90 words that we use in this aspect of biology, make sure you see that video. It's going to help your understanding of these terminologies. Now we have the mesocap, is the layer in between. Then we have the innermost layer, which we call the endocap. the endocarp. Okay, so mesocarp, exocarp, and endocarp. These three form on this end. I will now write pericarp. Both of them, the three of them rather, are called pericarp. And then the innermost portion here, this thing here is solid. Is that okay? It's not a hollow. Is that okay? It's solid. It's the seed. Do you understand? So you can see basically that the structure is such that it's housing a seed. The structure of the fruit is such that it's housing or protecting a seed. Of course, this portion here is the pedicel. The pedicel or the stalk. Is that okay? The pedicel or the stalk that arises from the funiculus. Okay, so basically, okay, so you're going to see the structure. We have the seed, we have the seed, and we have the pericarp. So the seed comes from this innermost portion here is going to be so this portion here is going to be if this place, I think the labeling is not really, okay. This portion, this outside here is the exocarp, this portion here is the mesocarp, and this innermost portion here is the endocarp. Is that okay? Exocarp, mesocarp, and endocarp. Okay, so this one here is just the structure, the labels of the seed. Is that okay? This portion here is the seed coat, or we call it tester. And don't forget that the seed coat or the testers is the one that covers the seed. It covers the seed. So then I think this portion here is just the endosperm, and this one is the cotyledon. Is that okay? This will be the cotyledon, and endosperm here. Okay, so provided that this is an endospermic seed. Okay, so we said the structure, pericarp is the ovary wall. Yes, remember that we said that the pericarp develops from where? The ovary wall that surrounds the seed. Of course, the ovary already surrounds the ovules, which the ovules will turn to the seed. So the pericarp will be formed from the ovary wall that already covers the ovule, which will then in turn cover the seed. And it has three regions. We have the exo or epicarp, the mesocarp, and the endocarp. Now the structure, the parts of the pericarp, we have the exocarp, which is the outer part, the skin of the fruit, mesocarp, the middle part or flesh of the fruit, and endocarp, the inner part, which includes the seed. Okay, now you're going to see that here in this mango. You see this is your endocarp. This endocarp is just the fiber you see here, the part here, because this portion that encloses it here, this guy that encloses it here is actually called the tester. Is that okay? But the endocarp is just, you see, for this mango now, the endocarp and the mesocarp are basically, together. Do you understand? Then there's the exocarp, which is the thick greenish or yellowish part in this case when it becomes ripe though. So then this is so you can see. So when you break this part open, you will now see the covering that I was talking about, which is the tester. You can see the covering. Okay, so we have, of course, this is also a tomato plant, showing the placentation. You see that? So and as you can see here, this is what? Axial placentation, because it is around this a central axis, right? The central axis. So we have the placenta is this middle here, the funiculus that holds the seed to the, to the center here. Do you understand that? I mean, it's the funiculus that anchors the ovules to the placenta. Is that okay? So that's just that. So then we have the endocarp. You see here that the endocarp and the mesocarp are together, isn't it? And almost inseparable. Even the exocarp too is quite inseparable because it is thin for this kind of fruit. It is very thin. The exocarp is very thin, and it's called the berry. It's called a berry. Okay, we'll get there soon. Now we have this structure for a pear. Yes, this is a pear, avocado. So you're going to see this, the seed. You see that? See the endocarp, see the mesocarp, and see the exocarp. So you see, the exocarp is also slim. It's also slim. Okay. Then we have the apple. Is that okay? We have the apple, an example of a pome. It's also a fleshy fruit. So far, we've been seeing fleshy fruits. So you're going to see that it is a now this guy is actually um, a we said it's a pome, yes, and a fleshy fruit, okay, with seeds, and it has the stalk. You see, now it is formed from other inflorescence. Is that okay? So now I was supposed to mention this from the beginning. We have false fruits and true fruits. Is that okay? We have three types of fruit. We have the false, the true, and the parthenocarpic. Now, parthenocarpic. If you remember in the beginning of reproduction, we talked about parthenogenesis. Okay, so false fruit are basically fruits that come from the ovary and other parts, other inflorescence of the flower. So that is how they are formed, the false fruits. They don't come only from the ovary, but other inflorescence such as the receptacle, the sepal, those parts, they form a part of the fruit. Is that okay? So that's why you can see this is the stamen here, this is the calyx here. All of these parts are still embedded in these fruits. So this will be a false fruit. Is that okay? Then now the true fruits are the one that arise from only they arise from only an ovary. Only the ovary give rise to them. No other part of the inflorescence. Do you understand? The fruit is a product of just the ovary and the ovary alone. That's what we call the true fruit. Is that okay? The first fruit is also called the accessory fruit. Accessory fruit. Okay. Now, another thing, so then the parthenocarpic, we said or mentioned that parthenos, the word parthenos here means virgin, right? So that's why we said parthenogenesis means what? Virgin birth, right? So virgin here refers to the fact that this type of fruit, parthenocarpic fruit, are the ones that arise without the fertilization of an ovary. So they arise without the fertilization of the ovary. The ovary simply turns into the fruit without being fertilized. Example, and those kind of fruits are also called seedless fruits. They're also called what? Seedless fruits, because they don't have seeds, because there's no fertilization. Example is banana. Does that make sense now? For example of true fruits, tomato that we just saw. For example of false fruits, seedless fruit, banana, pineapple, those guys, they are seedless. So that is why they are parthenocarpic. The condition of forming a fruit without fertilization is called parthenocarpy. Is that okay? Parthenos meaning virgin, don't forget that. And carpi from the word carpos, which is the Greek word for fruit. Okay. So we now have different classification of fruits. We have the simple fruits, the aggregate fruits, and the multiple fruits. The simple fruits are the ones that develop from one single ovary containing one or more carpels and may or may not include additional accessory structure. Does that make sense now? They develop only from a single ovary, so we call them simple fruits. If it arises from only a single ovary. While the aggregate fruit is the one that will emerge from what? Many. So remember, so we have simple fruit is like this. The classification is just like this. Simple fruit will be one ovary, one flower. But the aggregate fruit is going to be many ovaries, one flower. Don't forget that. That's the aggregate fruit. While the multiple fruit will be what? Many ovaries, many flowers. The multiple fruit is also called the composite fruit. Composite. It's also called the composite fruit. The composite fruit. Okay, so that is so I repeat that the simple fruit is what? One ovary, one flower. For the aggregate fruit, many ovaries, one flower. Then for the multiple fruit or composite fruit, many ovaries, many flower. Example is the pineapple. Is that okay? Then for the aggregate fruit, many ovary, many flower. Some of our berries, strawberry and the rest of them. Strawberry, raspberry and the rest. Okay? So now let's discuss the simple fruit. Let's discuss the simple fruit. So now let's talk about the fleshy fruits. And the fleshy fruits are the ones that um, the walls become soft and fleshy as they mature. The walls become soft and fleshy as they mature. And we have the types of fleshy fruit. We have the drupe, the berries, and the pome. The drupe, the berries, and the pome. Now, in some textbooks, like I've said before, you might see where they add um, Hesperidium and the purple under the types of fleshy fruits. Now, that is still correct, only that in this classification, they are grouped under berries. You see, the Hesperidium and the purple are types of berries. An example of the Hesperidium is the orange. Is that okay? Orange is an Hesperidium. You understand? So we group them under these berries. We group them under berries. So of course, just like orange is an example of Hesperidium, the watermelon is also an example of purple. Okay, so that's basically that. So, but the major thing about fleshy fruits is that they have a soft pericarp. Remember, I just told you now about fruits, and the fruits consist of the pericarp. So in this case, their pericarp is soft. Now, it is not always soft, but most of the case, for most of the kinds of fruits that are fleshy, the pericarp is soft. Now, then, so we said the drupe, the berry, and the pome. Okay, these are the three major classifications of the fleshy fruits. Now, the first one is the drupe. Now, the drupe has fleshy outer part, but a hard and stony endocarp. So that's why we call it another name for the drupe is the stony fruit. So, fruit. Okay, and the reason why it's stony is because the endocarp is usually hard. It's usually hard. So for example, you are going to notice that in mango, except the mango is already almost deteriorating. That is when you see it very soft. You understand? But a relatively ripe mango will appear, the endocarp will be hard. And of course, the another example is this one is very common with coconut. So the endocarp is stony. The endocarp is stony. You see that you have to break through the endocarp. You have to break through the endocarp then before you now come in contact with the white guy, the whitish guy. So this whitish guy is going to be the endosperm. Of course, there are two endosperms there. We have the solid endosperm in the coconut, and we have a liquid endosperm or fluid endosperm. Okay, so the here this hard structure, that brown hard guy, husk, we call it the husk, that is bordering the guy is going to be the endocarp. All right, so here, according to my slide, I said a one-seeded simple fruit developed from a superior ovary. Yes, that's one other thing you should note. It is developed from a simple ovary, the drupe, from a superior rather ovary. We'll call it a pygyny. Now, do well to see that video where I talked about 90 terms in plant reproduction that you need to know. So just make sure you see that video. Now, the the innermost portion of the wall, which is the endocarp, becomes hard and stony. Remember that the pericarp encloses the seed, in which is the oval that became the seed. So that innermost portion, which you call the endocarp, like I just showed you, is going to become hard and stony. Is that okay? So that endocarp is what in coconut will almost be impenetrable. You understand? You have to break it. Then the outer portion becomes relatively thin skin. So usually in the case of coconut, for example, the epicarp and epicarp and mesocarp are fused, more like they are almost, they have actually fused, because immediately after that epicarp, you cannot really separate that epicarp from the mesocarp. Is that okay? So but basically the mesocarp of that guy is fibrous. Is that okay? Not fleshy. So for drupe, the mesocarp can either be fleshy or fibrous, albeit it's still classified under the fleshy fruits. Is that okay? And so that is one thing that differentiates it from the berry. All berries are fleshy. Exactly. All berries have fleshy endocarp. In fact, in some fruits, in some berries, the endocarp and the mesocarp and the epicarp are all fleshy. So basically the pericarp of some fruits are fleshy, all the entire pericarp. Is that okay? At maturity. So we said the middle portion of the skin and the stone, that is the mesocarp, becomes either fleshy or fibrous, as we see in cherry. Is that okay? Or the African star apple that is known as agbalumo. African star apple. People also call it cherry, but it's actually, the cherry is actually the more like the generic name, because there are many other fruits that we call cherry. The species, there's another species that we call cherry separately. So I would rather we call that agbalumo African star apple. African star apple. Okay, basically, let's go to the next one. So an example here is the peach. So I'm going to be seeing the peach here. So you see the peach is hard. You see the peach? You can see the peach here is hard and stony, isn't it? Then, of course, this place is fleshy. Understand? And you see here that the endocarp, the epicarp, and the mesocarp are almost inseparable, right? Okay, so then you see the seed. Okay, so that is the peach for you. Then we also have the plum is another type of fruit. It's another type of drupe rather. So the plum is another type of drupe. We have the mango also. I didn't add mango to this example, but I added coconut is another example. So you're going to see the husk here. The husk is fibrous. The husk, we said, is fibrous. So you're going to see it's fibrous, and of course here is the endocarp. So this is the endocarp. Let me relabel that. So this is going to be the endocarp, the mesocarp, and the epicarp. You see that these two guys are inseparable here. So I said epicarp, mesocarp, and this one endocarp. So when you get into it, you now see the endosperm, which in this case is solid here, and of course in this case here there's also a liquid endosperm. That's the juice we get from the coconut. Okay. Now if a fruit is fleshy and it has a hard stony pit, and it contains a seed, then it is classified as a drupe. Okay. Now drupes are covered by a thin skin derived from the outer tissue layer of the ovary. The soft fleshy tissue below the skin is derived from the middle layer of the ovary, and the hard one is derived from the inner layer of the ovary. Now when you crack the pit open, it reveals a single seed that is formed from an ovule that is contained within the ovary of the flower. And coconuts, for example, have fibrous walls instead of fleshy walls that we find in most fruits, most drupes. Okay. Another fleshy fruit is the berry. Now I said drupes and berries are commonly asked in your exam. Try the difference between them. I'm going to be seeing some examples, some differences here. While the drupe can be fibrous or fleshy, the berry is always fleshy. Then the drupe is always the drupe, the berry rather, always has many seeds. It has many seeds, but the drupe has only one seed. So for example, you see in coconut, one seed. You see in banana, this guy. Yeah, banana is also a berry, Okay, I was talking about drupe. So you see in coconut, a coconut contains one seed, mango contains one seed. Which other one? Mm, which other guy? Grape too contains, no, sorry. Um, which other one? Remind me of fruit. Okay, so we have mostly they contain one seed. Is that okay? Most of them contain one seed. But berries, most of them contain more than one seed. You see banana, tomatoes. Under Hesperidium, we have orange, or watermelon. You know, in this one, the watermelon, you know, you cannot even, many of us even swallow it with seed. Understand? I remember a joke then that my elders, my elder siblings used to say that you would, that you swallow it, that it will grow in your belly. So there was one such day they said that thing, and I don't know if I was the one that said it, but a friend, I think, is either I said it was either me or the friend. So we said that if it grows inside us, then it means that we'll never be hungry again, of course, because it's going to fill us up. All right. So the point is, the berry is um, contains many seed. It contains many seed as opposed to the drupe, which contains one seed in most cases. And examples of berry, there are two special types of berry. We have the Hesperidium and the people. But other examples of berry include tomatoes, as we can see in this slide here. We have tomatoes or tomato. Tomato is American pronunciation. Tomato is British pronunciation. We have grape, we have banana, we have watermelon. Those are berries. All of them are berries. We have which one again? These big guys now. Which other one? No. Apple is not. No, not cucumber. Cucumber, yes, cucumber is going to be a berry too. Yes, because it's under people. Cucumber is going to be under people. Which one again? No. So those are just those examples. Let's stop there. It's okay. Thank you. All right. Um, so we have a simple fruit in which the ovary wall, or at least its inner portion, becomes enlarged and usually juicy. So that's grape, banana, gooseberry. Then there are two special types. We have the Hesperidium and the people. Let's quickly consider those. We have the common berries, the tomatoes, the Hesperidium. Now let's talk about the Hesperidium. Now the Hesperidium is a special type of berry that have leathery ringed forms. Is that okay? They have leathery rings. Is that ringed or rind? Okay. And segmented juicy interior. Now let me change it. So they have, so you're going to see, you see this partition I'm making, is that okay? Or segmentation, okay? Segmented juicy interior, leathery rings, and basically that's it. So did you see that? So, and the interior of the fruit is divided by septa. So those divisions are called what? Each one is called a septum. Each one is called a septum. So of course, the septum simply means separating. Um, you know, the septum simply means a boundary, a wall. Is that okay? A wall. All right. So now, I said that these guys are, and that septa actually indicates numerous carpels. Is that okay? That septa indicates numerous carpels. So it's showing that it is not just one carpel that forms this fruit. So it's showing what? Numerous carpels. That's why there is what? Segmentation. There's segmentation. And of course, oh, thank you. So we said the rind is leathery. So you're going to see this rind here is all of this portion here. Covers all of this portion here. And the rind is formed from what? It's going to be what forms the epicap. God bless you. Yes, because it's the outside portion. Yes, God bless you. So then we have the, of course, now you see that they are fused there. They are fused. The mesocarp and the epicarp. The mesocarp and the epicarp, they are fused. But of course, here we now have the endocarp that is juicy, like we said, and is divided by septa. Is that okay? It's divided by septa, and of course, and so the point is that these guys they are also they are also berries. Why? Because they have many seeds. They have many seeds. Okay, and of course, the most common examples are just the citrus family. We call them the citrus. What is that botanical name again? The citrus fruit family. That's citri. How did I just forget it? Okay. So the citrus family, like orange, lemon, lime, those guys are all under Hesperidium. So this the Hesperidium. So you can see the rind there. See the rind there. And of course, this whole wall here. We call this entire wall here the rind. It has a juice that is irritating to the eyes. Is that okay? This guy here, it has a juice that is irritating to the eyes. One of the reasons is for protection, but we're not getting into that now. So you're going to see one that is cut. The longitudinal section of one is shown here, showing the seed, and of course, so this here that you see is a carpel. This one is a carpel. This entire place is a carpel, but this separation you see here is a septa. Is that okay? The separation you see here, these lines that you see here is a septa. Okay. And of course, we have the lemon. This is another lemon. Okay. And this is another Hesperidium rather. So then the next thing is the people. Now the people is a berry that has a relatively hard rind. So in fact they have the hardest rind of all berries. The people have the hardest rinds. Is that okay? Remember, it is not coconut. Coconut is the hardest in the drupe, while people is the yes, purples have the hardest rinds. For example, if you punch a coconut not so hard, you're going to discover that it's hard. The epicap is harder than that of a if you punch orange and you punch a watermelon, you discover the watermelon is harder than that of the coconut. Is that okay? So the peoples, they have hard rind and many seed too. Is that okay? And the gourd family, is that okay? We call them, just like we call that one the citrus family. We call the one that the most common examples there, we call them the gourd family. Is that okay? Then the watermelon and the squashes. The squashes. So example is the pumpkin. Is that okay? Example is the pumpkin, as you can see here. So, and then we have the couples. You see the couples. See the couples, and you see it's showing the placentation. What kind of presentation would this be? Now put down your answer in the comment section, or at least you can DM me the answer to that. What kind of presentation is hey in all the fruits that we have considered, just the ones we have seen the picture? Tell me the presentation that you see them possess, because the longitudinal sections are shown. So show me let me know the kind of presentations that they possess in the comment section below. All right. So that is that about the people. Now you have locals, because we use the word locals here to show the partitions. Is that okay? The partitions. The partitions. All right. Then another thing is what else do you have now to know about this guy? We have seeds. Yes, you have the seeds, and the seeds are embedded within carpels, just like we saw in the case of that other guy, the Hesperidiums. Hesperidium. Okay. Now we have the cucumber, as you can see, and we have the so you can see the rind and of course the seed also. The seed. Tell me what kind of presentation this is to. Now we have the pome. is the last type of fleshy fruit that we'll be looking at. So a pome is named after the French word for apple. Does that make sense? An apple in French is known as maybe pomme. I don't know. So, but the idea is a pome typically is a fleshy fruit. So is that okay? And it has um, the entire thing mostly edible. The most part of it is edible. It's not just the ovary. Do you understand? And it comes from many other parts. Is that okay? So we call it a false fruit. You understand? That's why we call it a false fruit, because it is not only the ovary that gives rise to the edible parts. Do you understand? Other parts of the fruits, other parts of the inflorescence give rise to the edible part. So we say it's an accessory fleshy fruit. So accessory or false. Is that okay? Accessory fleshy fruits formed by a group of carpels more or less firmly united with each other and surrounded by and united to the floral tube or receptacle. Example is the apple, the pear, the mountain ash. Okay, then so what you see here is the pear. Is that okay? This guy here is the pear. Okay, so then we also have that for this reason it is called an accessory fruit. A pome is an accessory fruit composed of 5 or more carpels in which the exocarp forms an inconspicuous layer. All right, there we have the apple, as you can see here. So it's showing the exact presentation here. I will mention the presentation. Also mentioned this. Also mention this in the comment section. This is the longitudinal section. This is the a cross section. This is actually a cross section. A cross section, and we are observing dorsally. When you observe a cross section dorsally, that is if you cut the apple. Let's say this apple now was a whole apple. If you cut it here, and we begin to view from the top. So that is the cross section there. Okay, but you can see the seed, of course. You're going to see the pulp, the pedicel or the stalk. Is that okay? The pedicel or the stalk. And of course, you're going to see the remains of the sepal. The remains of the sepal. The remains of the sepal. And of course, we also said said many things about this guy, about how that the pedicel also is from the funiculus, isn't it? That attaches the oval to the placenta. So that is that. The pulp, from the perianth. So the pulp from the perianth, I mentioned the fact that peri means surrounding or around, and anth from the word anthos. Anthos is the Latin for flower. Is that okay? What does that mean? It means that other part of the inflorescence form the flower. So that is just to make sure you understand why we call it the false fruit. We call it the a false fruit. Now let's get to the dry fruits. The dry fruits. Now the dry fruits have their own pericarp dry at maturity. The pericarp or the coat is dry at maturity, and there are two major types. We have the dehiscent fruit. What does the word dehisce mean? I told you in my terminology that the dehisce means to split or burst open or break open, and that's the best word, to break open. So dehisce. Is that okay? It's a Greek word, and you see dehiscent fruit are basically fruit that split open to release their fruit. Their fruit that splits to release their fruit. So we said dry fruit which at maturity open by definite natural beings to shed the contained seed. Then indehiscent, of course, dehiscent means to split open, the ones that split open. Indehiscent, you know what? The ones that don't split open. Then we have another set which we call the schizocarpic. I treated that later. Schizocarpic. Schizocarp is in the last part of this video. So schizocarp. These ones are just in between the dehiscent and the indehiscent, because they also split open, but they don't release their seed. Is that okay? They don't. They open too, but they don't split because they want to release their seed. But this one split open usually by, that's the dehiscent, usually by explosive mechanism to release their seed, while indehiscent they don't split open to release their seed. So we have other types of the dehiscent. In fact, there are majorly three types that we consider. You have the legumes, the follicle, and the capsule. The legumes, the follicle, and the capsule. Now, you should be noted that it is these three that I'm treating with you that are the most commonly asked question in your JAMB and WAEC. So I decided, and that's why I decided to treat only these three. Is that okay? I'll probably treat other examples because, for example, in this thing, we didn't mention we didn't mention. So we have the legumes, we have the follicle, the capsule. Now I was talking about these guys, the the three major types that you see. So we have the legumes, which are you know, the major point here. Now you should take this note. The is a dry dehiscent fruit, like we have said. This thing is a dry dehiscent fruit developed from one carpel, and at maturity it splits along both dorsal and ventral sutures. So it splits on the two sides. That's the point. It splits on the two sides. I'm going to show you an example here. So look at this guy now. A pea is a legume. Is that okay? And they have what? Marginal placentation. So, oh God. You are going to write all the placentation. Is that okay? So I mistakenly mentioned this now. So make sure you write all the placentation. So this is a legume. You see, by the time you want to split, it's going to split, and they are called pods. Is that okay? It splits on both sides longitudinally. Okay, so then also wrote here that it's so examples are beans and peas. Those are the two major examples. No, there are other examples. Is that okay? We have this one that we commonly granules. So you see, now it is, you see, groundnut is under legume, yet it is called a nut, and a nut is actually an example of the indehiscent. Yes, of the indehiscent fruit. We have nuts, we have caryopsis. So nut is, yes, not, so groundnut is not a nut. Is that okay? So it's just by common term, just like we say strawberry, raspberries, mulberries. Those guys are not berries, actually. Is that okay? Those guys are not berries. All right. So follicle um, is a dry dehiscent fruit developed from one carpel also, and at maturity, this one will split along only one of the sutures. So this one will split along only one of the sutures. Example is the columbine, while the capsule developed from several carpels. Is that okay? And it also splits in various ways. You can split in what we call the loculicidal. I think I treated that right. Yeah. So we have the loculicidal. This is just mouthful. Is that okay? The name loculicidal. I'm going to give you the origin of the words so that you get it. It could be septicidal or is it down denticidal. And there's one down, I think poricidal, yes. So those are ways in which capsule can split. Capsule splits in different ways. But legume, don't forget, legume, your groundnut, your beans, your peas, they split on both sides longitudinally. Follicle split on only one side. Okay, so let's go. Legumes, they split along two lines of dehiscence. following maturation and drying. Yes, so they are dry dehiscent. Does that make sense? And dry indehiscent. The legume type fruit is derived from a simple ovary, one carpel, and two rows of ovals. This type of fruit structure is characterized of peas, peanuts, beans. The peanut is one of the few legumes that does not split open when ripe. Of course, the peanut does not split open when ripe. Now, it is probably because of the peanut develops in the soil rather than in the air. So, of course, you know the one. So, for example, beans that develops in the air is going to split open. Is that okay? You have seen where beans is being harvested, but peanuts does not do like that. Granules does not do like that because it's inside the soil. Understand? So that's that about legume. So we have seen this example. This is another example. This is our groundnut. Okay. So now we have the follicle. It's a dry dehiscence developed from one carpel also. And for example, the columbine and the milkweed plants produce fruit that is known as follicle. And the fruit of the follicle type developed from a single ripe ovary and split once. Very importantly, take note of that, guys. Split once. The other guy legume split on two sides to release their seeds. Then the splitting is also lengthwise, that is the entire length of this thing. Do you understand? So I said that legumes, you remember, split along two edges of the carpel. Okay. So this is the columbine. So you're going to see it splits once. Is that okay? In one section. Does that make sense now? So then we have the this is another type of follicle. We have the bay magnolia, or the botanical name is Magnolia virginiana. Then we have the milkweed, which is also a follicle. We have so this is the milkweed. So that's basically it. Then let's talk about the capsule. So the capsule is a dry dehiscent fruit that is developed from several carpels. Now what differentiates capsule is that it splits in many different ways. Is that okay? It splits in many different ways. Example is the cotton seed. Is that okay? Example is the cotton seed. Another one is lily flower, the lily plant. So unlike the legume, the capsule is composed of more than one carpel. That's another thing. So two things differentiate this guy. The other two, they have one carpel. They are made from one carpel. Is that okay? One ovary and all. While these other guys are made from several carpels. And why capsule rather are made from several carpels. So we have fruits like lily split lengthwise into sections corresponding to the number of carpels. Okay, so sometimes some split according to the number of carpels that make them up. So for example, this lily, this shows the longitudinal section of the lily. So you're going to see what kind of presentation is this to. Very simple. So you put that in the comment section also. Then the seed, you see the way they are arranged. Very simple. It's just the same thing. You understand? So this is longitudinal section where in which this guy is split into. This guy is broken into. So of course, when he wants to split, he's just going to split into. For example, we could split into for this one. In this case, could split into 1, 2, 3. So you could split downward like this, or downward like this. Is that okay? So that's a capsule though. So then we now have types of capsule. We have the loculicidal. Now the word loculicidal comes from the Greek word. Let me change the color. It comes from the Greek word. Okay, let's split it. Local and licidal. That's loculus. Does that make sense now? Loculus and loculicidal. So side. When you hear side, it means to die, to kill. Is that okay? So or to cut. Basically, it can mean to cut to a hand. So because if you remember the word suicide, you remember the word patricide, those words. So it means to kill. So local side, that is split based on his what? Locals. locules. Locules are just segments inside the guy, segments inside the capsule. Do you understand? So if it's split open along the walls of each of those locals, each of these locals, that's how it splits. Is that okay? So so it basically like cut itself into chambers. Do you understand? So then there's the petal, the sepals still persist, and of course the pedicel, right? So an example is the yucca fruit. You see, it's a loculicidal. You see, it splits along the locus. You see that? You see that it now splits itself into this segment chambers. You can call them chambers, and of course they are separated by septum. Okay, and we have the pedicel. So now we have the datura too. Datura is also an example. Now we now have the second type, which is the poricidal. So poricidal simply means pores, right? From the word pores. That is, so it's gotten from the two words pores and side. Side, kill, pore, holes, right? So it means that this one opens its rows, right? It's round holes to discharge the seed. So those are poppies. Examples are poppies. So then this one, denticidal. If you look at this thing looks like tooth-like. This portion looks like tooth-like portions, right? This portion looks like tooth-like portions. So that's why we use the word denty. What the word dentos? Is it dentos? Yeah, dent. Dentition. If I talk about dentition, you know what that means, right? So when we use the word dentist also, means tooth in how the dentist. IS was usually Latin, right? I don't know, but that would be Latin. I think Latin. So that's so cider means the tooth-like portion just break apart. Is that okay? So in a denticidal capsule, small teeth at the top, right? At the top of the fruit split open to release the seeds, as in corn cocoa or Agrostemma githago. Okay, the githago. Now we have this septicidal. Now the septicidal basically means what? Septum, right? It's divided into septum. So this one breaks along the septa. Breaks along the septa. Okay, so one splits along the septa and opens at the top. E.g., the Dutchman's pipe. The Dutchman's pipe. I also have the cilic. So the cilic is a special form of capsule, and it has two carpels only. It has two carpels only. So an example is the mustard family. Seeds, the uh, the fruits under the mustard family, they are what? Majorly they are majorly what? Silics. They are silics. That's the cruciferae. Okay. All right. So then we also have the silico. It's a special short broad capsule of two carpels. Now we have the pyxis. Now the pyxis is a capsule which has circumscale dehiscence. Example is the plantain. Is that okay? Example is the plantain. Right. But the major ones are the ones I first discussed. Is that okay? Those septicidal, whatever. Is that okay? But these guys are also under them, under the capsules, the pyxis, the silic, and all. All right. So then we now go to the indehiscent fruit. What does that mean? Indehiscent means do not split open, right? They don't split open. Indehiscent, that is not splitting. Okay. So these are dry fruits that do not open their when they are mature to shed their seeds. Many of these groups are one-seeded fruits. Many of them, they are one-seeded. So an example is the akin rather. So akin is a one-seed fruit, we have the nuts that I mentioned. Okay, I didn't add that here. B, C, D, E, F. Basically, There's also the caryopsis. Is that okay? Caryopsis. So caryopsis is grouped under basically, you see, the third category that I mentioned, schizocarp, is grouped under indehiscent here. Do you understand? So you might see some classification that will separate them. Some classification will put them together. Okay. So let's go to the achene. The achene are the one-seeded dry indehiscent fruit, and the one seed is attached to the fruit wall at a single point. Example is the sunflower seed, the buttercups, the dandelion, and one seed which is free of the pericarp, okay, is free of the fruit wall. So you can see the hepatica, the sunflower achene rather, and the dandelions. Is that okay? Dandelions, you know, they are the dandelions actually, you know, they have feathery. Should have seen this before. Should have seen it before. That's how they disperse their fruit by wind, by their seed rather, by wind. Okay, they just that's why they are feathery. Is that okay? They are feathery. So that's how they disperse by wind. That's why they are easy to disperse by wind. We also have the anemone. The anemone too is also dispersed by wind. From what you can see here, it's feathery. Okay. Now we have the nuts. The nuts is a dry indehiscent, one-seeded fruit similar to an achene bud with wall greatly thickened and hardened. So one major difference between this one is that between this ones and the first one is what? And the achene is what? This one have what? Hard pericarp. Does that make sense? And also one seed. They have one seed. Now example is the beech, the coconut, the chestnut, the oak, the hazel, the walnut, and hickory. Is that okay? Right. So sorry. Coconut is not under here. I mistakenly mentioned that because I remember that I said because of extrafloral bracts or husk, the later two fruits are sometimes called drupes. Coconut too is called what? A drupe. Do you remember? So walnut too is also a fruit, is also a drupe. The hickory is also a drupe. Okay, so then we have the burr oak, the acorn, the chestnut, and the samara. Okay. So I mean the samara is, excuse me. The samara is another example. Is a wind achene for wind dispersal. It's a special type of achene actually, but I separated them here. Is that okay? So it has a wind. It has a winged. Is a it's seed. It is wing. It's winged. Wing seeded. That's how to say it. It's wing seeded. I said it's one or two seeded dry indehiscent fruit in which the part of the fruit wall grows out into a wing. So we have the maple, for example, we have the ash, we have the elm. An achene with a wing, that was what I said before. Okay. So we have the maple, the ash. So those are that. Then we have the grains or caryopsis. So most of our series are under this group. Most of our series. E.g. the what's this guy? Maize, thank you. Corn, is that okay? The seed, the corn. Does that make sense? So we have the wheat, all those other series. Wheat, which one again? Or rice. Yeah, they're under this group. Is that okay? So that is that. That is caryopsis. Now one thing with the caryopsis is that their seed coat is fused with the pericarp. Don't forget that. I said that the seed coat is fused with the pericarp. Okay, so let's go to the next one. We have the schizocarp. The schizocarp, they are formed from a compound pistil, and that compound splits into Mericaps. Is that okay? Mericaps simply means pieces. Is that okay? So that is going to be the end of the class. That's going to be the last one we're going to be considering under this in this class. Actually, there's another classification of fruits that I probably have not mentioned before in class, and that one is just according to how many seeds they bear. So there are some fruits that have only one chamber for seed, and we call them unilocular fruits. And then the last one we call them multilocular fruits. Multilocular. Multilocular. Okay, so this one have multiple chambers for their seed, one chamber for their seed, one chamber for seed. And this one, many or multiple chambers for seed. Okay, to house their seed. Is that okay? So example, the one that have multiple chambers for seed, what? Tomato. You understand? But why this one have one chamber? Example, our peanuts. Is that okay? So that's just all that we have for this video. Do well to subscribe to the channel. God bless you. Bye for now.